Uh, just wait for 2-3 minutes more so other can join. Okay, let's start. I hope I'm audible to all of you. Please give me thumbs up or you can unmute yourself. Anyone? So I can start my session. Okay, thank you. Okay. So in previous session also we discussed about what is the data center topology, layer 3, layer 2 designs, and what is the meaning of generic layer 3 and layer 2 designs. Again, I'm going to start with this slide only. Why? Because it's important. Okay. So what is the meaning of data center topology? Or so let's learn about what is the data center topology. So topology generally refers to how different network devices are connected and organized inside the data center. So that is mean of data center topology. Okay, what is mean of that? How different network devices are connected and organized inside the data center. So that is mean of data center topology. It generally defines how server are communicates, how data flows, how scalability and performance are achieved. Okay. So let's discuss about the layer 2 and layer 3 basics first. So a typical data center use a combination of layer 2 and layer 3 topologies or technologies. Layer 2 basically means for switching. So it's generally works using the MAC addresses. It used for the communication within the same network. Okay, what happens in a layer 2? Which layer 2 generally use MAC addresses for communication, and it's within the same network. So, and it also supports the WAN, virtual LAN, and fast switching, and it is commonly used at the access layer, that is a server connectivity. Second one is a layer 3 routing. Layer 3 routing generally use the IP addresses to communicate with a different network. Okay, it provides routing, traffic control. We can say we can use this. We commonly use this layer 3 for the aggregation and core layer. Okay, we already learned about what is the access layer, what is the aggregation layer, and what is the core layer in the previous unit. So, what is the need of combining layer 2 and layer 3? So, the using of both layers together generally provides the efficiency, scalability, flexibility, and reliability. So, that is why we generally combines this layer 2 and layer 3 technology in a generic server form. Now, what we are going to see, we are going to see the generic, or we are going to discuss about what is the generic server farm topology. Generally, generic topology. See that we already seen in figure 4.6. Let me take that. Okay, so this is what a figure 4.6. Okay, so generic topology shown here only. So here we can say the multiple servers connected to the switches. So we have the different switches here. See, these are the layer 2 switches, and these are the layer 3 switches, or you can say layer 2 and layer 3 switches over here. So what we say, the multiple servers. So here we have the different servers: generic server, web server, application server. So these servers are connected using the through the switches. In layer architecture, I hope you're. I'm going to repeat it again. At access layer, we have the different server. At aggregation layers, we have the layer control. Okay, and at core layer, we have the backbone of the system. So this design generally supports large number of servers. Also, it efficient traffic management. It having the efficient traffic management, and it is scalable. Okay, so that is why the generic farm designs are really important. Okay, now again we are going to see the what we can say that generic servers from the topology, how we are going to use it. So here just discuss about this diagram. So here we have at the top of we have the IP network. Okay, which generally present this IP network generally presents the external network, or you can say the core network connectivity. Below that we have the aggregation and access layer. Okay, so these are aggregation and this is what access layer. So this layered approach generally helps in better management, scalability, and performance optimization. So let's talk about what is the aggregation layer. So this is what an aggregation layer. It contains the multiple switches, either that maybe layer 2 or layer 3 switches. Here we have the aggregation 1 and aggregation 2. So the two switches here we have. These switches generally perform the routing. So routing generally performed by the layer 3 switches between the different network, and switching is performed by the layer 2 within the that particular network. Okay, what are the key responsibility we can say about that? It acts as a gateway for the servers. It handles the traffic control and routing decisions, and it connect to the external networks using the IP network. So this is a critical control point, is the aggregation layer. Now what about the access layer? In access layer, again we have here only layer 2 switches. Okay, so this switch, this kind of switches provides the direct connectivity. So you can observe here direct connectivity to the different servers. Okay, direct connectivity to the servers or different servers. So it connected it connected to like the generic server, database server, mainframe system. Here we have see generic server, database server, mainframe system, servers with the internal and external storage type. Okay, so I hope you're understanding the what the actually layer 2 switches did. Okay, so what is the key responsibility of layer 2 switches? It connects the servers to the network and handles the local traffic switching. Also, it provides the high port density. So this is the server facing layer, we can say that. Okay, so connectivity between these two layers, aggregations and access layer, um, these are generally redundant connections. It provides the multiple path. These are the generally redundant connections. Why we use the redundant connection, that again we are going to discuss. Every data center has the redundant connection that we are going to discuss in upcoming slides too. Okay, why we have this kind of connections? It provides the high availability, load balancing, and no single point of failure. Okay, so I hope you understand this diagram. Hmm. Now, layer 3 functions, we are going to see the layer 3 functions. Again, uh, let's focus on the layer 3 functions performed by the aggregation switches, which are very important in data center topology. So the first thing is what here, the packet based forwarding. Okay, where in this we are going to forwarding the packet based IP on that particular IP, or you can say the layer 3 information. So this means the data coming from the servers is routed to the other networks, or you can say the internet or other data centers or data segments, said data center segments. So unlike layer 2 switching, which use the MAC address layer 3, the IP addresses to be decide the path of the system. Okay, this ensures the efficient communication between the different networks and proper traffic flow across the data center. Okay, next point is like the maintaining a view. So aggregation switches maintains a view of entire network. View of entire network means what? It looking at the routing tables, different network path, and available routes. So this is the dynamic view, we can say that. Means when we talked about the dynamic, means it updates automatically when the network changes, any kind of occur. For example, link failure happens, so automatically it will be goes to the another part or another routing table. So another routing part, so the user will not feel any kind of failure. Okay, so the system adapts quickly without the manual intervention. Okay, third, that is support the default gateway. So aggregation switches also act as a default gateway for the different servers. This means when the servers want to send the data outside its network, it sends the traffic to the aggregation switches. So these switches then decide where to forward the data. And again, this is a critical because all external communication depends on the this default gateways. Okay, why these functions are important? So this layer 3 functions generally ensures the scalability, means that supports the large network, reliability when it adapt the failures, different kind of failures, and efficient routing, means what? It gives the optimal data flow between the that particular network. Okay, now we are going to see the layer 2. We are going to focus on the layer 2 functions performance and aggregation switches. Oh yeah, so which are again essential for the maintaining a stable and efficient network. Okay, here the most important part is what spanning tree protocol. So let's understand what is a spanning tree protocol. So we have in a data center, we have the multiple redundant link to ensure the availability, redundant path, or you consider redundant link to ensure the availability. However, this multiple paths can create a network loop. Okay, what happens if multiple loops, network loops are created, it may cause the broadcast storm, network conjunctions, and system failure. So to prevent this, we generally use the spanning tree protocol, STP. Okay, there again the different version over there. We are going to discuss this one also, but I hope you understand what is mean of spanning tree protocol. So STP generally creates the loop-free topology by blocking the redundant paths and allowing only the active paths. Okay, so there is a very high enhancement between the STP, that is spanning tree protocols, like the 802.1W, that is the rapid STP. Okay, 802.W, that is what a rapid STP. You can say that it gives the faster conversions, and it helps to reduce the downtime. Similarly, for the this 802.1 S, this we can say the multiple STP, which supports the multiple virtual LANs efficiently. This 802.1 S. Okay. Also, we have the concept like the uplink and backbone fast, uplink fast and backbone fast. So it improves the recovery time during any kind of failures occurs. And what is the loop guard? So it prevents the loop due to the link failure occurs. So these enhancement make the network the faster and more reliable. Okay. Now VLANs for the logical separations of the server farms. This means the different applications or departments are isolated to improve the security and performance. For example, the web servers in one virtual LAN and database servers in another virtual LAN. We can say that. Additionally, layer 2 has different services like the we can say the aggregation switches that also supports the multicasting, ACL, okay, access control list, which controls the traffic is allowed or blocked. QoS, that is the quality of service, okay, which generally prioritize the important traffic, for example video and voice. Third one is a rare limiting. So sorry, not rare, it's rate limiting, means it controls the traffic flow, and the broadcast separations, so it prevents the excessive broadcasting traffic. So why this layer 2 functions are important? Again, these functions ensure that the loop-free networks better performance. You can say the security and controls, also efficient traffic management comes over there. So that is why these layer 2 functions are very important in data center management. Let's discuss about what are the access layer switches and server types. Okay, some parts. So let's understand this one. So what is the role of access layer here? Um, we can say the access layer is the closest layer to every server, as we look in the previous diagrams. Okay, so you can see that in this diagram. So here, this access layer is the closest. You can say the closest for all the servers. Okay. There we are. So this access layers are the closest one. What does that mean? Provide the it provide the direct connectivity to all servers in the server farm. What does that mean? All servers are physically connected to the access switches, and it act as the entry point for the every server communication. Okay, so there are different types of servers like the generic servers, mainframe servers, and database server. Okay, so let's discuss one by one. What is the generic server? So there we have the where we have the common services like such as domain name system, which converts the domain name to IP address. DHCP, that is mean of data. Sorry, not data, dynamic host configuration protocol, which assigning to the IPs. Okay, FTP stands for the file transfer protocol, which transfers the file, and telnet for the remote login. So these are the basic network services, service providers that we use in the generic servers. Next one is the mainframe servers. You can say that it is a high performing computing systems which use for the large scaling processing and enterprise applications. So this may be used for SNA, that is system network architecture and internet protocol for the communications. Okay. Next one is a different types of data servers. That is a data server. We stored and manage data. Generally, it is critical for the different application, transaction, and business operations. So these are the most important servers in the many systems. There are again different storage types that is built inside the servers, includes the hard drive and taped unit. So it's simple to direct connected. There are also external storage which connect outside to the servers, typically uses small computer system interface. Okay, generally it is used for the large storage needs like and the better scalability. Okay, so this what is the important of this access layer? What we can say, it provides a high speed connectivity. Also, it is efficient in communication between the servers, and it supports the different server types and storage systems. So the access layer plays the critical role by directly connecting to various types of servers and ensuring the efficient communication and the data handling within the data centers. Now, what we are going to see, the connectivity between the aggregation and access layers. We already discussed this thing, but now we are going to deep more detail and deep dive into in this connectivities. Okay, so let's understand this aggregation switches, access switches, and servers in data center. So first one is a ether channel between the aggregation switch. Okay, so let's first look at in between the aggregation switch. So they are connected using the ether channels, that aggregation switches. Ether channel means it combines the multiple physical links into the one logical links. What is the meaning of ether channels? It combines the multiple physical links into the one logical links. It generally increases the bandwidth and reliability. So these links operate in a trunk mode, which means they can carry multiple virtual LANs over the single connections. So also it supports the 4096 virtual LANs. So you can imagine what is the benefit of ether channels. Okay, so but obviously it ensures the high capacity and efficient data flow. Okay, next one is what uplinks. So here the connection between the access to aggregation. So let's look at the connection from the access switches to aggregation switches. So this is called the uplink, access switches to aggregation switches. Okay, they can be single links, or you can say the low it is used for the low traffic, and multiple links also there, or ethernet channels for the high traffic we use. So this uplink also use trunk mode. What is meaning that it's use the multiple virtual LAN that can be passed through one physical connections, and this provide the scalability, flexibility, and we can say the efficient use of the network resources. Okay, last connection, that is what a server redundancy, or you can say the dual homing. Okay, so let's focus on a server's connectivity, where servers are connected to two different switches. This is called a dual homing. Okay, where servers are connected to two different access switches. So this is called a dual homing. So this each server has like NIC, that is mean of network interface card, with the two ports. So these two ports works in a active and standby mode. These two ports actually works in a active and standby modes. So one port is active and other is on a standby. So when suppose one main server port is collapse or fail because of some reasons, so another one will get whatever which is on a standby, it will be get activated. Okay, and take over the all this request. Okay, so here we have the failover mechanism. So if the active link fails, the standby port automatically takes over, and it use the same MAC address, IP address. So from the network perspective, there is no interruptions. Okay, so the question is why this kind of uh, designs is important. So this kind of connectivity generally ensures again the high availability, load balancing, scalability, reliability. Okay, so this connectivity designs generally ensures the the data center network is highly reliable, scalable, capable, and handling the failure without affecting the service. And this is the most important thing for the every data centers you can manage. Need for what we can say, the need for layer 2 at access layer. What is the need of layer 2? So what we can say, the traditional use of the layer 2 at access layer, or access switches have been traditionally been layer 2 switches, meaning they operate using the MAC address, which provide the fast switching within the same network. So this design is also commonly used in a campus network wiring. Okay, so the idea of using the layer 2 at the access layer is not a new. It is a well established practice. Okay, similarly with the campus network, what we can say, similarly with the campus network, the access switch is connected to end devices like the computer, printer. Similarly, in the data centers, access switches are connected to the server storage system. So the basic functions remains the same. Okay, it generally provided direct connectivity. What is the basic function? It provides the direct connectivity. Okay, so while layer 2 is preferred at access layer, the first thing is a fast communication. Second one is a simplified design. Third one is the efficient. Okay, so this layer the fast, simple, and efficient connectivity that making it an ideal choice for server communication in data centers. Okay. Layer 2 at access layer, how it works. So, like server group, we have the different types of servers. And what is the server grouping concept? Here we have the server grouping concept. In data centers, servers are oftenly grouped based on their functions. For example, FTP servers, file servers, database servers. Okay, or the based on the department owner size. So ownership size. So on that basis, what we are going to do? We are going to group the servers. Okay, so these group servers are placed in the same virtual LAN. These group servers are placed in the same virtual LAN. Why same virtual LAN? So whenever servers are in the same virtual LAN and they belongs to the same subnet, they belongs to the where same subnet communication, they can communicate directly using the layer 2 switching. So this ensures the faster communication and low latency. Okay, there is different types of supports it provide, like server to server communication and clustering protocols. Okay, so many application requires the frequent communication between the servers, like the web servers want to communicate with the application server wants to communicate with the database server. So this communication is faster when the servers are in the same subnet. Okay, like next point, you can say the clustering the protocols like heartbeat combination. Um, Clustering protocols means what we can say. It in advanced system, servers works in a cluster. So cluster servers, we can say the continuously exchange the signals that is called the message, heartbeat message in clustering. So this message monitors the server health and ensures the failover support. Okay. Important point, what we can say, the some of these protocols are not routable or cannot be passed through the layer 3 to maintain the security. So they must operate within the same subnet, or you can say the layer 2 networks. While layer 2 is necessary, again, some communications requires on same subnet, or it cannot be routed. So in that case, layer 2 ensures that the direct communication and compatibility with the clustering protocol, and it also maintains the efficient application performance. Okay, so this is all about the reason why we are going to use the layer 2 at access layer. Additional reason, what we can say that like the first one is the dual home server. So but obviously we require the redundant one. Okay, so servers are usually connected to different access switches. This is called the dual homing. It generally ensures for the high availability and no single point of failures. Okay, so each server has an active interface and standby interface. Okay, both interface must be in a same virtual LAN. That is the most important condition for that one. So same VLAN means what? It must be in the same subnet and same default gateway. Why? Because the standby interface take was the username, IP address, and MAC address. So this seamless traditions this is possible only because of if we keep that both in a same network, or you can say the same subnet and same default gateway. Here the most important concept comes, that is horizontal scaling of server farm. So I hope you are very well aware of vertical and horizontal scaling. Okay. So horizontal scaling of servers farm, where the data centers grow horizontally, meaning new servers are added alongside the existing one. Okay. Um, it must be placed in the same virtual LAN subnet, and as the server performing the similar functions. Okay, so if one switch runs out of the ports, the new switch are added, and same virtual LANs is extended to the new switches. Okay, and generally this again ensures the flexibility, easy expansion, and no need to redesign the complete networks. Okay, it generally support for the stateful devices, where the data center use devices like the load balancer, firewall. So these are called the stateful devices. These are called the stateful devices. While virtual or why the layer 2 is important for the stateful uh, devices. The first thing, stateful devices tracks the session or connection information, and it generally requires in both the inbound and outbound traffic to allow the same path. They also continuously exchange the session or their state information. So this generally requires the layer 2 adjacency or same matrix. Okay. So without layer 2, session may be break, or traffic may inconsistency may occur in traffic. Okay. So this is again the another important reason for the layer 2 at access layer, we can say. Multi-tier design. Okay. Uh, the multi-tier design, which is widely used in a modern data center, where the first thing what we can say, the application model. So most of the application follows either the client server model or entire architecture. Okay. In a client server model, the simple architecture are there, and the client communication directly with the servers. Okay, in entire model, what we can say, the most advanced and scalable application is divided into multiple layers or tiers. Common tiers in the data center, what we can say, the client tier, web server tier, application tier, database tier. Okay, so again, these tiers perform the specific function, making the system modular, scalable, and easy to manage. Okay. So communication between this kind of tiers, we can see the client to the web server to the application server, and application server to database. So this is how we are going to communicate in one after another. Okay. Uh, Again, what we can say, so this multiple tier design is essential in what we in a modern data centers to build the scalable, secure, and high performing applications by separating the functionality uh, to different we can say the layers. Okay. Now let's understand the multi-tier application diagram. This is what a multi-tier application diagram. It is a very important architecture used in modern applications. Okay, so the first one is again IP network. So at the top, this represents again internet, external users, and client devices. All user requests originate from the system only. So first is what aggregation layer. Again, it contains the multiple switches, that is L2 and L3, and it handles the routing and traffic control. So I don't think so. I need to explain this the aggregation layer protocols or switches. Sorry. Okay. Next comes the front end. So when we talked about the front end layer, which contains the web servers, so this is the first point of the contact for the users. This front end is the first point of contact for the users, which generally handles the HTTP and HTTPS request on a web server. So for example, when you open a website, your request goes to the that particular web server. Okay. Next comes the application layer. So this application layer contains the application server, which responsible for which is responsible for the business logic and data processing. Okay, for example, processing the logging and handling the transactions. So we can say that one. Okay. Next one is what the backend layer. At the bottom we have the backend layer. So this is what a backend layer you are. So at the bottom we have this backend layer, and it contains the database servers and responsible for the data storage, data retrieval, storing user data, fetching product details. Okay. So for that reason we use this one. Okay. Uh, and the last we can say the flow of communication. So user to web server to application, and application to database server. So each layer performs an specific task or responses from the following reserved paths. Okay, so this is all about this diagram. This is what the network service icon. Again, this is 4.10. Uh, Let's understand this diagram, which shows how the network services are integrated to a multi-tier data center architecture. Okay, so this is an advanced design where the security, performance, and scalability services are distributed across the layer. Again, the first IP networks. Next is the aggregation layer. So at this layer, we deploy the key services such as the firewall, load balancer, SSL offloader, and the IDS, that is intrusion detection systems, and cache. Okay, these layers actually act as the security plus traffic control center. Okay, next come. Okay, give me a minute. Okay, next come the application layer, which contains the application server. Uh, which contains the application server, which having the business logic and transactions. Uh, I don't think so. We need to mention the more detail regarding the application server, and which generally having the firewalls, load balancing, SSL offloading, and all these things. Backend layer, that we say that it contains the database servers, which generally used to store user data, application data. So this layer is highly secure and having the limited access and protect by the firewall system. So why services are distributed across the layer? So instead of placing all the services in one place, they are distributed to it for the improve the performance, enhance security, provide the scalability, and what we can say reduce the bottleneck. Okay, so this is all about this diagram, network service icon. This diagram we are going to cover in next see again, this is same diagram we have, only the representations are different. So this is a collapsed multi-tier design. uh, what is a collapse design? So in traditional multi-tier design, each layer is connected step by step, like a web server to the application to database server. So each steps are connected, and but in collapse design, these layers are still logically separated but physically connected more directly. So this reduces the complexity. Okay. Again, the top layer we have the IP networks. Okay. Aggregation layers. So at the aggregation layer, we have the different. We can say this is the code of the every design. It contains the multi-layer switches, network services. It directly connect to the front end application and it directly connect to the front end application and backend layers. Okay. Unlike the traditional design, all layers are connected directly to the aggregation layer. So this ensures in the faster communication and redundant latency. Okay. Also here we have the front end layer, which handles user request and connect directly to the aggregation. Second one is the application which process the business logic and directly communicate with the aggregation. Third one is the business, sorry, not business, backend layer, that is a database servers which store the data and directly connects to connection improve to speed and efficiency. Okay, so there is nothing big in this diagram. Okay. Next one is a fully redundant layer 2 and layer 3 design. So that we are going to discuss in upcoming sessions only. Okay. So just wait for 2 minutes so I can take the attendance of you. Okay. Just unmute yourself and call your roll number 1 to 5.
Roll number 1 present.
Okay. Next,
Roll number 5.
Roll number 4 present.
4 and 5. Okay. Next, 6 to 10.
Roll number 6 present.
6 present.
Roll number
Okay.
8 present.
Sorry,
8.
8 done. Roll number 11 to 15.
Sir, roll number 11.
11.
Sir, roll number 12.
12. Okay. Next,
Sir, roll
roll
number
number
15.
Okay, 15. Okay, 16 to 20. 15, 16, 17, 18, 19, 20. Okay, good.
Sir, roll number 18 present.
Sir, roll number 10.
यार इतना लेट क्यों बोला?
सर वो माइक नहीं चालू हो रहा था सर.
अच्छी बात है. 18, 19, 20.
Sir, roll number
20.
18.
Done. 21.
Present, sir. Roll number 21.
22, 23, 24, 25.
Sir, roll number 26.
Sir, 23 present.
20
Sir,
present.
24 present.
23 present. 24 present. Who's next?
26.
26 present. Okay. Who's next?
29.
Sorry?
29.
29 directly. Okay. 29 present. Who's next? 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. No one? Okay.
33 present.
Sorry? 33.
33, sir.
33 ना?
37 present. Yes,
37. 33 झालं राहिले. Sorry?
Sir, 41.
40 का? 40 का
41.
41? 41. Okay.
39. 49 sir.
Okay. हो गया 39 भी हो गया. ओके सो 20 स्टूडेंट्स का मैंने अटेंडेंस मार्क किया. होप सो मैं यहाँ पे चेक करूँगा उतने ही लोग हैं. ओके हैव अ नाइस डे.